Hello guys, let's derive the equation of the circle x square plus y square equals to r square. So, we have solved many problems using equation of a circle and related to geometry, algebra, etc. with this equation right here. But have you ever wondered where did it come from and how do we derive this? Well, for typically 2D shapes like these, you will have to go to the definition to help you derive the equation. So, let's look at the definition of a circle. So, in a math language, circle is defined as the locus, which means the shape that is made, the locus of a moving point in a plane, right? Such that the distance from it to a fixed point at any time is equal. What that means is, let's say we have a moving point right here, and this fixed point is called the center, and this distance over here is known as the radius. So at any time, this point on the circle, this distance will always be the same. No matter where the point is, it will always be equal from this fixed point over here known as the center. So I'm going to write the definition right here. Now we have to use this definition to derive the equation of the circle. Now let's make a xy coordinate system over here, and let's put the center in the origin because the equation which I had written in the thumbnail was for the circle at the origin. But in fact, you can do it for that center at h comma k or whatever center. It's going to be very easy and very similar. So this is the origin, call it O. And here, let's look at a point in the circle. Let's call that point x1 comma y1. And let's look at another point. Let's say this and call that x2 comma y2. Here x3 comma y3, and here x4 comma y4. Now let's move on to the definition. Blah 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 blah, such that its distance from a fixed point is always equal. So this means that this distance is equals to this distance is equals to this distance is equals to this distance. So this distance will be equal to root x2 whole square plus y2 whole square, which will be equal to root x3 whole square plus y3 whole square, and so on. Now we can just square both sides to remove the square root. So x1 square plus y2 square is equals to x2 square plus y2 square is equals to dot dot dot, and in general we can write it as x square plus y square. Now we have found the left hand side of our equation. So x square plus y square is equals to r square. Now for the right hand side, go back to the definition. So all the way over here, the equal distance is known as the radius. So this distance is the radius, so is this, so is that, so is this. So that means one of these distance, root x1 square plus y1 square, is equal to r. And when you square both sides, you'll get r square. Right? So finally, from here and here, you get x square plus y square is equals to r square. There we go. That is the equation of the circle in the origin, or sorry, at the origin. But what about at any center, at any point, let's say h comma k? Well, where did this distance formula come from? Well, it is x1 minus 0 whole square plus y1 minus 0 whole square. So instead of minus 0, you'll have minus h, x1 minus h whole square plus y1 minus k whole square. So in the end, you'll simply get x minus h whole square plus y minus k whole square is equals to r square. And yes, there is also another general equation you guys may know, which is x square plus y square plus 2gx plus 2fy plus c is equals to 0. Well, you get this kind of equation when you kind of just open up these whole square forms and you turn them into quadratic forms like this. And this is why you can also find the center, which is minus g comma minus f, and the radius, which is root g square plus f square minus c. So let me show you right now. So in order to find the center and the radius for this equation of the circle, you're going to have to somehow make it in the form of this over here, such that you can simply compare them and get the center and the radius. So right here, all you need to do is simply complete the square. So for the x, we have x square plus 2 into x into z. So this is like a square plus 2ab plus we need the b square, which is g square. And since we added g square, let's just subtract it. And similarly for y square, we can also do that. Y square plus 2 into f into 2 into y into f plus f square minus f square plus c is equals to 0. Now this part is simply x plus g whole square, and this part is simply y plus f whole square. And you'll have minus g square minus f square plus c is equals to 0, right? We'll put that on the right hand side. So this becomes g square plus f square minus c. And now simply compare these two over here. So our center is going to be h comma k, and since this is positive, it will be minus g and this will be minus f. And the radius square will be equals to this. So r square is equals to g square plus f square minus c. So therefore the radius is equals to root g square plus f square minus c, like this. So there we go. We have derived the equation of the circle, as well as we have found, or from the general equation of circle, we have found the center and the radius of the circle. So this is the definition over here. And to derive more shapes like circles and even parabolas, hyperbolas, ellipses, etc., just go to the definition and try for yourself just by making the figure. If you learned something new, please like and subscribe. Thank you.